how we roll there. Some rock, some wind, some 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 wind.
I was about to say some things have changed since last time. Some things have not changed. Let me start again from scratch. Yes, I failed to unmute myself. Sorry. So welcome everybody to Zig Showtime number 37. It's been a while since the last one ran, and a few things have changed. I still mess up controlling OBS, I guess, but the format is slightly different. Previously, Zig Showtime was a show where people would come and give a talk. We're not doing that anymore. So now we're transitioning to a more, I guess, podcasty style in a sense. So that means that the guest will not give a talk start to finish and then Q&A, but instead it's going to be more like an interview. So I'm going to ask them questions. They will still screen share and demo whatever they're working on, show some code if it makes sense to do so. But it's going to be more interactive. That also means that we will be accepting questions from the audience throughout the entire episode. So if you have any questions at any point in time, feel free to type them in chat. Ideally, try to tag me so that I can see that your question is directed at the show and it's not just people chit-chatting in Twitch chat. Then, other announcements. Well, the show is resuming, so now I will need people to come on stream and show cool stuff if, to schedule a new episode. So if you know of any interesting Zig project that you would like to see on Zig Showtime, let me know. You can find me via email. You can find me in my Discord server. You can find me on social media. I would say the order of preference should be like email, Discord, social media. So yeah, let me know. And in case you have an interesting Zig project that you would like to show off, on zig.show, the official website of Zig Showtime, you can find a form where you can submit an application, and I'll take a look, and and then we can organize a new episode. So other updates. Tomorrow I'm gonna do a live stream in the European morning, so that means 10 to 11 a.m. Let's say 11 a.m. Central European time, where we're gonna talk about Zig and Rust, and it's not gonna be a Zig versus Rust thing. So that's what you're into. Go watch another stream. You're not gonna find that here, but we're gonna chit chat about things. It should be fun. I think Togglebeat is a very funny guy, so it's gonna be more interesting than my usual streams where I just do stuff that I have to do. So after that, another announcement. Zigtoberfest is returning. So I don't know, has anybody here in chat gone, did anybody here went to Zigtoberfest? Type 1 in chat if you've been to the Zigtoberfest. There weren't a ton of people, so I get it if nobody is present here right now. Is it Zig Plus Drinks? It is, kinda, yes. So Zigtoberfest is a one-day event organized by David Sugar in Munich. Yes, that is in Germany, in Munich. It's organized, I don't remember the last one was, I think the last one was also in October. This next one is going to be on the 22nd, 25th of October. Go to zigtoberfest.de. I'm going to put a link in chat. I'm going to actually type it out now. Zigtoberfest.de. Go check it out. So this October, there's going to be another Zigtoberfest. The last one was awesome. So if you want to meet some people, I'm going to try to be there again. So if you want to meet with other people in the Zig community, try to be there. It was a fun event. It was a free one-day event. Very fun, very nice. We did German things. So throughout the event, there were like boxes of bottles, glass bottles with Spezi in it. Spezi is a ungodly concoction made up of, I think it's cola plus orange soda. Maybe some Germans can correct me if I'm wrong. In any case, it was fun. It was very typical. No, don't say. The American that says, ooh, no. You should try it out. You should be more open-minded. Anyway, it was nice. It was nice. And we also had pretzels. So that also was nice. Okay, last piece of announcement before we get into the episode. Zig 014 is about to come out. So in case you didn't know, there was a news announcement. It's about time to get 014 out the door. I think Andrew hasn't started working on release notes yet, but this is going to start soon. So you should see Zig 014 come out in February. So you know what? If you have a Zig project, maybe now it's a good time to start thinking of updating to new Zig, because as you know, new Zig means new breaking changes. It's part of the deal. Okay, this was it. So let me finally introduce the guest for today. His name is Jim Calabro. He is a software engineer at chess.com, the chess.com. And apparently, in his free time, he's been working on a debugger written in Zig from scratch for Linux with a GUI. Can you believe this? So please let me welcome Jim. And yeah, Jim, how are you?
Thanks for having me.
Okay, sorry, you were also muted again. do it again.
Hello, I'm good. How are you?
Okay, thank you. I'm also good. So very nice to have you here. So is there anything else that that you want to share about yourself with the audience? Like, what's your favorite chess opening move?
Sure. I play the ready, which is uncommon, but and it's non-confrontational, which might say something about me, but I'm not so sure.
Okay.
Yeah.
Nice. So I guess before we get to the demo part, I guess the first question that one might ask, if you get on Hacker News, which I believe you just did, right? I think the announcement blog post just got on Hacker News.
Yeah, we're currently on Hacker News, second story.
Second story, nice. So why do we need a new debugger on Linux? What's wrong with what we already have?
Yeah, it's a great question, and it's a little bit of an emotional question. It's like I've spent so many years fighting GDB and LLDB more recently, and honestly, they're just not good. Like, they crash all the time. They don't display the data I want. Like, the user experience of the command line programs especially is really bad. Like, I really don't like pressing N and F like all the time and flipping through all your frames, and like it doesn't make your data like very quickly apparent. So in general, I'm not a fan of command line debuggers, but even still, with something like DAP, there've been a lot of new UIs built around these existing debuggers, which are better for sure, but still not good enough, if you ask me. Like, for years, I was using VS Code with LLDB as the backend, and I still use that actually to debug Zig because my debugger's not far enough along yet. But I don't know, it still just kind of sucks. Like, for my daily work at chess.com, I actually switched back to command line LLDB because it's just substantially more stable. Like, I would run into issues where VS Code would actually freeze. It would completely crash my MacBook when I had to debug stuff on Mac. Like, it's just not a good situation. And yeah, it just leaves a lot to be desired. I think we can do a lot better. I know we can do a lot better. And yeah, so I just started working on this project just kind of for fun mostly as well. Like, I needed this thing. I still need this thing for my own work, but also it's just fun to program like really low level, like nitty gritty stuff, and to learn something you didn't know before. Like, I didn't know anything about Dwarf or Elf before starting this project. And so it's been a learning experience, and I've leveled up quite a lot along the way. So yeah, I still need it for my daily work, and it's a lot of fun. Yeah,
makes sense. Yeah, I had I think it was a few months ago where I had a stream where I was trying to debug my application, and I was fuzzing a parser, so I was dealing with strings, and my input was a very long string, and I wanted to see the substring that was causing the parser to misbehave. Yeah, what a mistake! Trying to print a substring, it took forever to figure it out. Jacob Lee helped me out. Jacob Lee, who is also in chat, helped me out, and it was ungodly to just a substring.
Yeah, absolutely. And so actually, it's great that you mentioned him. So I saw he maintains a fork of LLDB that implements Zig specific stuff, right? That's pretty awesome. But also like, so this is kind of jumping ahead to, future plans for this project, but why can't a debugger be hackable, right? Like I'd love to be able to extend the debugger in such a way that you can build it out trivially for your own custom data types. You can build custom visualizers. You can work in a new language that maybe isn't very well supported like natively. Like, C++ support is pretty good everywhere, but like something like Zig or like Odin, like maybe you have like you can have better built-in support for your like common data types much more quickly. And you can do that to a certain extent with LLDB, like with like the various Python plugins and GDB as well. But it's obviously you kind of reach a bit of a silly point where you have to fork the whole project to add Zig support. So yeah,
makes sense. Okay, you want to show us what it looks like?
Sure. Are you able to see my screen?
We are, yes.
Awesome. All right. So I've got the repo open here, and I'm just going to show a very trivial example just to like kind of show that it's not like smoke and mirrors or anything like. And this is all built from scratch, by the way. So all of the elf and dwarf parsing, the like control of the sub process that you're actually trying to debug, stepping, like getting data out of the subordinate process and rendering it in a user-friendly way. All that stuff is written from scratch. Basically, the only dependencies are like glfw and DRM GUI, which are packaged nicely from the Zig game dev project, which is awesome. You should, go check them out. But yeah, all that stuff is like written from the ground up. And here it is. So it's a GUI debugger. And on the left here, I've loaded up a simple Zig program that just prints out a bunch of basic values, right? It's got a bunch of ints, it's got some bools, it's got some C types, it's got some floats, it's got a string, right? And enum just prints them all out at the end, right? So very straightforward program, doesn't actually call anything else. That's all it is. Then you click R to run, and now we've broken in the debugger at the first line. And so you can actually see that there's a bunch of uninitialized variables in memory because we haven't actually initialized them yet, right? So this is just all the stuff that the operating system gave to you when you actually got into this function. This is just where that data was actually, you just happened to get this data. And now we're just going to step one line at a time. And we're going to see that, each of these variables is going to get set up to the value that we expect, right? So I'm stepping and stepping and stepping and stepping and so on, right? It's got a lot of the table stakes debugger features that you would expect. Like there's a watch window where you can enter like custom stuff up here, right? And if it doesn't know what it is, it just prints unknown. But anyways, we can continue on and actually skip down till I'm going to press C to continue. And now we're stopped and all of our data has been initialized and we're going to start printing data out, right? So just, you can see the output is going to come to the output window here. Make that a little bigger. I'm just going to print it all out. So pretty straightforward so far. But you can see that, there's some nice, there's some niceties of these like data visualizers already. So we have like a string, for instance, that is like just saying hello world. You have the address of it in memory. You click that, sends it to the hex window. You can see, actually, this was probably in like a read-only data section or something because it's stuck next to the word general protection fault, which is kind of neat. You can, visualize struct fields as well. So this is actually a struct that has a string and an integer in it. So you can see this is field B and, it's just right there. Yeah, it's got slices, strings, structs, enums as well. So if you actually look at the definition of the enum up here, it prints out the user-friendly name as well as the actual underlying integer value. Doesn't support tagged unions yet, but that's on my list. Yeah, you can see that it unwinds the call stack. So we're actually in main. Yeah, it's a lot of like the table stakes debugger stuff, right? I'm actually going to step into print as well. So you can see that when I step in, now we're actually in debug.zig in the standard library. And you can see, we're in the print function. We're going to lock standard error, get the thread ID, blah, blah, blah. And yeah, just kind of all works. So I just continued to the end of the function and it just prints it all out. Or I continued to the end of the program rather, because I don't have any more breakpoints, but you just click a line to set a breakpoint or unset, right? And that's largely it for like a simple example. Like we're still very much in like these are the table stakes debugger features that are getting implemented right now. and it works reasonably okay for Zig, and it works reasonably okay for C. I haven't started on C++ or Go or Rust or stuff like that yet, but a lot of the tech is the same. It's not 100% like with Go. They have their runtime, for instance, that you have to be aware of. But the plan is to get there. And yeah, so far progress is good. And I'm not exactly using this as my daily driver yet, but I can definitely see a world where it gets there like somewhat soon. So that's what I'm really excited about.
Nice.
Yeah. Now, let me show you a more interesting example. That was just like a simple program that just like, it's just a bunch of junk, right? You would never actually write a program like that. So I'm going to open up the config file and swap over to a more fully featured program. And let's run it again. Some of you might recognize this game. This is classic Doom. This is an open source version. And what I've done, I did this ahead of time, but I actually set a breakpoint. I'll come back over here and show the config file again. I set a breakpoint on this file on line 1222, which is actually the line of code that deals with area of effect damage. So when you shoot the barrel and you're close enough to it, it'll actually pause in the debugger, right? And so now we're stopped in this function, and we're going to calculate, hey, like what was the distance away from that barrel? And the distance was 79. And so if I keep stepping, and I'm going to step into check site to make sure that we actually are like in view and stuff like that. You can see I'm just doing debugger stuff. And then you can actually step back out. So I'm going to step out. Now we're back here. I'm going to continue again, and I'm going to tab back to the game. I'll do it again. And yeah, now we're here. And you can see like there's a big old stack trace down here as well.
Yeah.
So that's kind of it for demos, unless you want to see anything else or have any questions.
That's already a lot, right? That's as you said, table stakes definitely there. That's awesome. I think that since Zig is a new language and a lot of things are being attempted, it is understandable for like an onlooker to think, oh yeah, there's an endless amount of unfinished projects in Zig. Everybody is working on it in theory, but obviously people want proof that there's a certain like critical amount of seriousness behind a project, and it seems that you got it.
Yeah, it's the debugger is interesting because like there's like an infinite amount of work you could do on it. Like there's so many like bespoke visualizations that you could add. Like I work at chess.com, right? I want to add a visualizer for chess positions. So if I have just a variable that stores a single position, I want a chessboard to pop up, and I want it to be interactive. Like I want to be able to play a chess game in my debugger, right? Like how cool would that be?
Yeah. That makes a lot of sense. Okay, so there's a bunch of good questions from the audience. Andrew has has a few, which by the way they're all very compelling. So let me think in which order to ask them to you. Let's talk GUI. I think let's start with the GUI one. So right now you have you're using an immediate mode framework, right? What are you using?
Yeah, I'm using Dear I'm GUI, which is very popular.
Yeah. So that means that you have, in terms of dependencies, like runtime dependencies to your program, you have sysandar library and a bunch of other stuff, right? No, sorry. I mean more like run LDD so that we can see your dynamic dependencies. Okay, you don't have a lot.
Yeah, very few.
Very few.
It all gets built from source, if I recall.
I see.
Yeah.
That's cool.
But there are dependencies nonetheless. Like I would love to be able to statically link this binary and ship it, but like any graphical application on Linux, anybody will tell you like that's a huge pain in the butt. I hear it can be done.
Well,
I don't know. We'll see.
In this case, wait, are you not just depending on libc? Like, can you not just do muscle?
I don't believe so. The target equals, what is it, x86 64.
Yeah, you can do native muscle.
Oh, really?
Yeah.
I just upgraded to latest Zig as well, so maybe something's changed. But
okay.
I was building a bunch of C++ because DRM GUI is C++. Although I am using the C wrapper for it, so maybe this will actually work. Hey, look at that. Oh, yeah, invalid elf header.
Okay, something goes out of whack then.
Yeah, I'm not sure. I haven't actually tried this in a long time. Yeah.
Okay. It's a good application, right? So you, in any case, you somewhere at some point have a dependency on some other GUI related stuff. Like, you know what? Let me tie this back to the question from Andrew. Andrew was asking, like, did you see Gimli's project that lets you create a static Linux executable that can open a window and do GUI, but with CPU rendering only? So you would give up GPU rendering.
CPU rendering. I do GPU render right now. I had actually. Yeah. All right. Let me take a step back as well. So my plan for the GUI, I feel as though the GUI is not amazing yet. Dear on GUI is pretty good. It's great if you're like making a video game and you want to plug in a little helper menu and stuff. But as like your main driver of the application, it's just okay. Like it's doing the job, but it's not amazing. I have been strongly considering moving both off of GLFW and off of Dear on GUI, but it's just like there's just so much work to do. I'm more focused on the actual like core debugger stuff at the moment. Mock is very interesting. I've kind of been delaying until Mock is a little bit further along, if I'm being honest, so I can evaluate it more readily. But yeah, I'm absolutely interested in anything that can help me build a static executable and use GPU drivers, which again, I'm not 100% sure that you can do that, but I'd love to talk about it.
Yeah, I'm not an expert, like actually far from it, but I remember Andrew coming actually on Showtime and discussing the topic, and I think the general consensus was that it's basically very hard to get that working. As in, I think he created a static executable that was able to do GPU stuff, but I think some people were reporting that the example broke. Like it was basically not meant to be a well-supported use case. So let me put it this way. What I think it's interesting about what Andrew is suggesting, I think, is that yes, you would give up GPU rendering, but you would have a fully static executable. That is huge on Linux.
For sure. That's also an advantage. We were just chatting about this in the Discord earlier, but that's one advantage of having CLI debuggers as well. You know, it's obviously just CLI programming. You just ship it as a
good
static
point there. Yes.
Problem.
Yes.
But like, you know, that's sort of the user experience of a CLI debugger leaves a lot to be desired. So it's not a good trade-off for the sake of it. But if I was to build a CLI debugger, I would definitely do that.
Okay, so another question from Andrew, which is going to be funny. So he's asking what languages do you need to support for your debugging needs at chess.com, which ties back into the question, what languages are you using at chess.com?
Yeah, I mean, it's on our job postings on our website, so I think it's fine to say we use C++ pretty extensively for our chess engines. You know, most chess engines just are written in C++, though there have been a few that have come up in Zig that are starting to be very compelling. So keep an eye on those. So yeah, we mostly use C++, and then a good amount of the web server stuff that I work on is written in Go. And then we call the C++ via CGO. We have a C header that we expose, and so we use CGO to call into the chess engines in this particular case. So those are the two languages I use at chess.com that I will be adding. I'll be prioritizing support for. Also, I just really like Go as well. Like I've been writing Go forever. I did see your Lobster's comment, Andrew, on Go, and I replied to it, and it's good stuff. All your criticisms are extremely valid, and they are correct, but I still like it. So yeah, Go will come soon. C++ will come soon. Other languages probably not so soon, but C and Zig for sure as well. C is just so straightforward to support. It's a really great test language because, you know, if it works in C, it's the simplest language, so it gets down to the base case most effectively. And then Zig as well, because I want to be able to debug the debugger with the debugger, which I can't quite yet, but I see that in the relatively near future. That would be awesome. Yeah.
On a scale like 1 to 100, how far along are you with like C++ support? Like how much is missing?
Oh, it's not even started. So the way that a debugger generally works for native code is everybody speaks ELF and dwarf on Linux, right? Basically. So you have the same underlying code and the same underlying syscalls and the same underlying data format for all languages. What I really mean when I say I don't support C++ is I mean I don't support visualizing the common data types in C++. So like std string, depending on what platform you're on and what compiler flags you use, it's just going to look like a bunch of like garbled garbage in like the hex window most of the time until you actually find the char star buffer that you really care about, right? And so, you could load up a C++ program and like break on, like you can set a breakpoint on the first line and it'll stop there. But then it's just going to like not print out any of your variables. So it's not very useful. And so that's what I mean by language support.
I see.
It's not like you're rewriting like, for a language like Java or Python or anything like that, you would have to do like a lot of bespoke work because it's not in the same data format and it's very different. But yeah, something like C++, it's just like you got to go through the exercise of actually figuring out the right way to visualize XYZ data types on ABC platforms. And so like on Windows, there's this thing called NatViz that does something like that. LLDB actually has their pretty printers, which are pretty helpful in this regard. So we actually have our own custom LLDB pretty printers at Chess for our chess engines, and they're pretty effective. Not a lot of people use them, if I'm being honest, but they actually are pretty decent.
Zig
So
also
that's
has
what
pretty
it looks like,
printers
yeah.
for written in Python. I don't know if you saw.
Oh, sweet.
Yeah, in the Zig repo.
I don't use command line LLDB for
Right.
Zig. I use VS Code as my front end for Zig at the moment, and it's okay. Like it's not great, but it's fine. Like, actually, you know what? This will get Andrew mad as well. Open source Zug community. So I realized this recently, but I didn't know this till a couple months ago. But you can't use the open source version of VS Code as a C++ debugger with the CPP tools extension. Like if you install the open source version of VS Code and you try then to search on the extensions marketplace for the C++ debugger, it just doesn't come up. You have to run the Microsoft approved VS Code.
Oh, so they're not uploading it
not
to
great.
OpenVSX?
Yeah, whatever their like package registry is there, they basically don't support it in open source version. So it's very frustrating.
Okay, so if somebody was interested in like getting started with debuggers, like what would be a debugger? What does a debugger hello world look like if somebody just wants to, get started?
Sure. So the first code I wrote for this project was loading an ELF file and loading the debug info within that ELF file. So actually I can just pull it up right here, right? So elf.zig, this is actually some of the first Zig code I wrote, and it hasn't really changed too much.
Yeah, zoom in a little bit, please, so that we can also see it. Oh, if you have it locally, even better. Yeah.
Yeah, just a little bit bigger. So first thing I would do, load up an ELF file and read through all its sections. Like I was doing some read ELF a minute ago. So you're going to have to read the header. You're going to have to read all of these ELF sections is what they call them. So like it's just, within your executable file, this is where all the, the text segment is here, right? This is where your actual code lives. And then down below, you're going to see a bunch of debug underscore whatever. And that's where your debug symbols are. And so you're going to have to parse those as well. So yeah, on Linux, ELF gets paired with dwarf. They kind of are in the same thing. It's a little bit of a strange boundary. But yeah, you're going to want to read your debug information entries, which are basically like for every symbol in your, maybe symbol's not the right word, but for every like notable thing in your source program, like every variable and every function and every constant and everything. For all that stuff, you're going to want to read the debug info section to see what's in there, and it basically gives you back a tree, sort of like the analog might be like an abstract syntax tree in compiler terms. It's like the reverse of that, right? You want to get back to like it's called the debug information tree, and so you can do that with like you can actually visualize it pretty quickly with like dwarf dump. Like I have a C program here called cprint, and I'll just grab that real quick. And so you can see that this is just visualizing all your debug info. So it's declaring it's declaring your compiling unit, then a bunch of base types, such as like, unsigned int, for instance, and it's 4 bytes. And you're going to want to read all that. You're going to want to read through other debug sections. Like there's one called debug line, right? and this is where all of your line number information is stored. So it says, hey man, like this is main.c, and this particular address in memory, that's in your text segment that says, hey, this is a address in your binary. So if I do obj dump, if I could type obj dump -s assets c print out less cap and look for main. Here's main, right? So we're going to see, hey, this address actually is the start of main.
Yeah.
And you're going to just keep like going on down. And then if you keep scrolling down here, you can see all of the addresses correspond to some source line of code there. And so that's kind of how you can relate those back. And so basically what you do is you do this like static read of all the static data out of the executable. And then what you do is eventually the user of your debugger will want to launch the program. And so you start the sub process. And once you launch it, I actually have a fork of child.zig here. You're going to use this system call in Linux called ptrace, which is a it's kind of like a Swiss Army knife. It allows you to do all sorts of cool stuff. And it's just part of the C standard library. Basically, there's this one syscall. The first argument is like, hey, what do you want to do? It's just an enum of like request type. And then you'll give it a process ID and then a couple optional parameters as well. And using this syscall, you can control the behavior of the sub process. And so you can either set a breakpoint, you could read some data, you could read registers, you could read like from the stack, from the heap. You can write data, so you can actually change values in memory or change the value of a register and so on. And by combining these two things, like at a very high level, you're going to be able to actually compose them together to make a debugger. So for instance, like if you wanted to set a breakpoint on the first line of main.c here, you would look up in your debug line segment, you would say like, all right, in main.c, the user clicks main.c, and I can actually pull this up in the debugger if we want. Let's see. So I'm going to pull open, and I'm just configuring up these config files for now, but let's pull open cprint main.c, and I'm just going to do cprint, and let's go run it. You can see now we have this. It's very similar to the Zig example I showed before, where I just declare like one of a bunch of data types, and then it just prints them out at the end. So I'm going to just click and set a breakpoint, and I'm going to run the program. And just as before, it's all uninitialized, and then we initialize variables one by one. But the idea is when you actually click that line 22 here, you know that you're trying to set a breakpoint in main.c on line 22. And so what you have to do as the debugger is look up main.c, line 22, and then, all right, it's this address. I'm going to set a breakpoint at that address. Well, what does that look like? Ordinarily, in the text segment in your program, it looks something like this, right? Like line 22 is 401.160, which is right here. So it's doing a move. And so this little bit right here, that actually is the code that's saying, hey, set this variable a equals 1, right? What you do is you actually, there's a special instruction in x86. It's the trap instruction, and it's just C, I think it's CC, X, I have constant, yeah, OXCC. And it's like int3 is like the common name for like interrupt. And so what that does is it changes just that one byte of code from C7 to CC. And what happens then is when you run the program, when it hits CC, it hits that interrupt instruction. It actually tells the debugger back through that ptrace layer, hey, I'm stopped at a trap. I'm stopped at a breakpoint. And the debugger then says, all right, cool. Like it's time to actually do the thing of, call the function like I'm at a breakpoint, look up all the data, get the call stack, all that stuff. And yeah, so that's kind of the basics of it, right? It's very simple at the very fundamental level. That's where I would start, is I would start by parsing debug info, and I would start by just doing that very basic breakpoint control flow in the sub process.
Awesome. Yeah, that makes a lot of sense. So let's see. Let's continue with, let me see, audience questions. You know what? Also, in the meantime, Let's talk about also more like new features, innovative features. You mentioned some already, but before we get to the ones that you are thinking about, there were a couple of questions about supporting time traveling like RR does. Have you considered implementing something like that?
Right. So everything I've just described is not really how RR works. So
Yeah.
RR does a lot of like hardware specific stuff to, when you actually use RR, I guess we should say like RR is actually and it actually doesn't work on this computer, unfortunately. But RR is like the record replay debugger, record rewind, something like that. And what you do is you call RR on a program. So like RRLS, and it's not going to work in this particular case because I have the relatively modern AMD CPU and it just doesn't work, unfortunately. But what they do is as your program is executed, it's keeping track of like pretty much everything that happens to a certain extent, and is doing it in a very intelligent way that honestly is a little bit over my head. So I don't think I should go into a lot of detail there, but it's keeping track of what's going on. So what you do is you would call RR record LS or something, right? And then once you have this would actually run LS and it would save all of that runtime information to a file, and then you do RR replay and then give it like the path to the file. And I've used this every now and then at chess when I have like a null pointer or something like that. It's really nice to be able to say, I'm now stopped in the breakpoint because I had a null pointer exception, and it told the debugger, hey, like stop here. And I want to walk backwards to find where it actually was null, or the last time this particular address was changed or something like that. Like just for example. And that's like a very different model than a normal, like quote unquote traditional debugger like GDB or LLDB or microscope. And so I haven't put any work into that at all. I actually emailed Robert O'Callaghan, is the author of RR, and we were chatting a little bit, but it's a very different model. I haven't really made space for it yet. I am definitely open to the idea. In particular, so I have like maybe this is a good time to go into like my overall theory of debugging, right? Like my conceptualization of debugging, which is it's fundamentally it's actually not about bugs. It's really about collecting and visualizing data. Like you want to figure out what the hell your program's doing. And it's really less about like transitioning from a state of bug to not bug. And it's really just asking questions and getting answers. And so the way that I've structured this debugger is I've come up with like very simple, like almost like protocol isn't necessarily the right word, but like there's these common types that as long as you put data into this format, then you'll be able to visualize it, right? And so right now, all of the data collection comes from ptrace, as I was just mentioning, this system call, right? So the data comes from ptrace because that's what I'm using to implement this traditional style debugger. And then it gets visualized in our GUI. And so what I want to happen is I want over time, this is definitely a long-term plan, but over time, I want to move from only ptrace to also say eBPF or system tap or, like maybe even RR, right? If you could plug in, I probably wouldn't, I don't think I'm brave enough to go re-implement RR myself. That's a really crazy thing. But like if you had an RR like file, you could actually maybe load that up and visualize all of your data from that particular run that you did, right? So another tool that might be similar to that is Pronosco, which is also built by the RR folks. And it's basically like you do RR locally. You take that file that's generated and you ship it off to them, literally in like an email or something like that. And then they will email it back to you once they've done their analysis. And then you have this like absolutely baller UI to go do some really cool like post hoc debugging in. And it's ridiculous the amount of detail you get out of this, but it is really high latency, right? And so I want to have a debugger that does that sort of data transformation. Fundamentally, a debugger is just collect some data, run it through this transformation function, and visualize it, right? Maybe you like aggregate the data or something like that. And then you want to spit out like, aggregate of all the system calls that you made in the last 30 seconds or something. And RR can be a part of that. ptrace is a part of that right now. I could see arbitrary pluggable like data backends being a part of that, and then arbitrary, pluggable, hackable visualizations as well. So that's really like the long-term vision. We're a long ways off from that for sure, but the reason I'm starting with a traditional debugger is it kind of gives me the opportunity to really battle test it on a problem that I think a lot of people are having that's pretty important to solve. Like, I really need a better debugger, like a traditional debugger. And if we can build out the traditional debugger to do a pretty good job at that visualization, then in theory, we should be able to swap out what data ingest we're getting and be able to take in data from other sources and at least do something with the visualization of it as well, right? So that's sort of my little spiel about where I want to go with this thing.
Makes sense. So you mentioned that for R, you would need to do a lot of like architecture specific work. I guess then by contrast, like when writing a traditional debugger, can you get away with not doing a lot of bespoke work for each specific architecture then?
Yeah, there's actually relatively little in the way of like architectural specific stuff in the debugger. Definitely. And again, I don't support anything other than x86 right now, but like my x86 file is just, here are the registers and that's it. And the interrupt instruction. And yeah, there's going to be more stuff when I do eventually support ARM for sure. But yeah, it's relatively, it's well encapsulated in ELF and in Dwarf. And ptrace is a Linux syscall primitive, right? And so a lot of those are transferable between architectures, but a good amount of it does also. There's going to be stuff that has to change. For
Understood. Sure. Can you remind me? You do support macOS? Do you not?
No, just Linux at the moment.
Just Linux.
I do intend to also support macOS and Linux. And somebody actually asked about FreeBSD earlier as well.
Yeah,
I don't see why not. The idea is, not just the architecture, but also like the ptrace is like the data collection layer, quote unquote, for Linux. And on Mac OS, you just have to use macho primitives instead. And so that'll be something that we have to swap out. Like Mac OS also uses, it's a very slightly different format, but it does basically also use Dwarf. That's like only a part of the debugger though, right? You have to actually understand how macho and the kernel is going to interact with your debug symbols. So it's not so trivial, unfortunately, to just say like, hey, I'm going to go load up those dilids and disims rather. They use like a split Dwarf format. And it's unfortunately not as trivial to just say, I'm going to load those up and run the whole thing through ptrace, because ptrace on Mac OS basically doesn't exist. There is a ptrace syscall on Mac OS, but it's severely weakened. I mentioned that like ptrace has like a lot of functionality. Like you can like look at register values and you can set like register values. You can read memory, you can write memory. Mac OS ptrace is not the case. So it has ptrace, but it's very, very hampered. So you really only have like continue, which continues execution, and like kill and detach. Like it doesn't actually have any of those other critical features that you need when you're building a debugger. Like you need the ability to actually go look at memory and registers and stuff like that. So yeah, you gotta build it out on the side.
Makes sense. Yeah, I also experienced something interesting where the macOS equivalent of strace, first of all, it doesn't work unless you disable system integrity protection, and then I experienced my system freezing multiple times while attempting to use it.
I actually didn't even know macOS had strace.
Yeah,
are you talking dtrace or?
Kinda. It's dtrus, okay. DTRUSS, which I believe it's a wrapper around dtrace. And you can use that to basically obtain a list of syscalls. If you have disabled system integrity protection, if your Mac doesn't freeze.
I'm going to be honest, I've had really bad luck with dtrace on Mac OS as well. Every single time I've tried to use it, which is only a couple times, it's also frozen on me. It's one of those things that it's, we develop for Mac OS, but we actually don't ship for Mac OS except via WASM, I guess, because WASM has to run on Mac OS eventually. So I haven't spent a lot of time like actually in the Mac OS ecosystem. So
yeah, it's weird. It has become weirdly hostile to this kind of work. So
Yeah, it is very frustrating with system integrity protection, though. Like multiple times now, developers on my team have been bitten from like, we're writing C++, and some of our developers have Macs and they use Macs, and so there's like all this weird stuff when you want to run like a Go process that links to a C binary, right, and
yeah.
a C library, and yeah, so it's just been a nightmare. I just tell everybody to disable it, and that's kind of our guiding policy there.
So let's see. I have one last question for you directly from me. Then I'm gonna give more space to final questions from the audience, and then maybe we can call it a day.
Absolutely.
The question for you is, I guess it's two questions in one, very related. One is, how much mileage did you get out of the Zig standard library when it comes to things like you mentioned you wrote your dwarf parsing, ALF parsing yourself.
Yep.
Is there anything related to this stuff that was in the standard library that you found useful and could like lift directly? And second question, which is kind of related, is how was using Zig to do this kind of work compared to your previous experience using maybe C++?
Sure. I had looked at the dwarf stuff in the standard library, and at the time, this is probably about a year and a half ago. So this project's been going on for a while. It's just I've only open sourced it last week. This whole package has changed a lot, which is good because it's getting better all the time. I don't really want to keep interfacing with a package that keeps changing. And secondly, I think that fundamentally your dwarf package just has a little bit of a different goal set than I do. Like I want to read all of the debug symbols into like a common like type system, essentially, right? Like
Yeah.
I have this like let's see, like data type, right? It's got some number of bytes and it has a name and then some certain format of one of these, right? And it just really it was kind of trying to fit a square peg into a round hole. Like your dwarf package is very much, it feels as though it's written from the perspective of a compiler author rather than a debugger author.
That makes
which
total sense.
It literally is. Yeah.
I learned this
heavily
lesson,
inspired, as I say.
Yeah, I learned my lesson in this regard a while ago when working on a HTML parser for a language server. And basically what I learned is that your parser will be, like if you want to write a good parser for a given use case, it will be very different depending on the use case. So like saying, oh, I need an HTML parser. No, you don't. You need an HTML parser that makes sense for your specific use case. And I'm guessing the same applies to you.
Yeah, I think that's generally true. The other thing I'll say is I'm very like, I have a hard time when I know that something is slower than it should be. And there's a couple areas in the debugger where I know it should be faster. And so one of the things I'm excited about is I think that my dwarf parser is like real fast. Like it's pretty good. I think I've regressed far enough that I couldn't actually okay. So I basically went through like a full rewrite of like my internal type system a couple months ago. And I don't think I would be able to actually load up Ghosty nowadays, but like, let's see if I can actually get that going. Cause it's pretty fast, right? Like home, go source, GitHub, initial Ghosties, dig out. Let's just see if this works. And I'm not sure it will. We're doing it live.
Let's go.
And if it works, I'll build up a release build. Hold on, I got to turn on logging. Oh, geez. All right, my computer spun up super hard. So what I'm going to do is I'm just going to do a release build right away, and we can chat about other stuff in the meantime.
Okay. Well, you can answer the second half, I guess,
yes.
of the question, like how has Zig been treating you?
Oh, I love Zig. It's so good. Zig is like such a sweet spot for me. I mentioned I've been a Go developer for a long time. I appreciate the relative simplicity of a language like Go. It really hides away a lot of the like hard stuff of programming, like a web server, for instance, and it does an okay job at that. Zig is like I am in a similar mindset when I program Zig. It's like there's very little separating me from sorry, I got distracted now. So Zig really allows me to like not have to think about like language crap, right? Like I'm very much not like a programming language person. I don't care about fancy C++ features. I'm not really like super into like, I don't know, like any of the modern C++ stuff, right? It's just not my bag. I really like simple code that you can just look at it and you just read it and it's just like right there. There's very little in the way of abstraction. And so for a long time, I was programming C and Go instead of C++. And the thing about C is like, it doesn't have a good standard library and everybody's kind of gone off and written their own. And like some of them are okay. I did the same myself. Like I wrote my own like little like handmade, like if you're familiar with like the handmade community, I like went and did the whole thing of like writing your own code base. Well, that did like, you know, strings and arrays and atomics and like files and graphics and stuff like that. And it was a pain, right? It took a long time. It didn't work super well. Like it was a good learning experience for sure. But like you can just come to Zig and it's sort of batteries included for all the stuff you care about. Like one thing that really made me happy was like the threading library, right? Like threading primitives in the standard library in Zig are fantastic. If there's a deadlock, it tells you where all your threads that are deadlocking are. Like that's just so good. So yeah, big fan. Not just of the language. Like again, I'm not that into like languagey features. Like you might notice I write like relatively simple Zig still. Like when I look at like the Zig compiler code, I'm like, wow, I didn't actually know that was a thing you could do in Zig. But what I really care about is like the build system is really good. It's really fast. It's easy to use. It just gets out of your way, right? So that is kind of, yeah, that's my experience with Zig. It's been really fantastic. And I'm definitely going to keep using it for future stuff. But anyways, getting back to this. So if we go to Ghosty and just do like Zig out, and just do a dwarf dump of Ghosty and just pipe it to dev null, right? And time this. It's like 3.5 seconds. And this is a very powerful computer. And you'll notice that my debug symbol parser actually parsed it into the full usable format in 1.5 seconds. So yeah.
That's awesome.
Yeah.
Performance is a feature. For sure.
It is. Yeah, for sure. Yeah. So yeah, did that answer your question about Zig? I can get into specifics if we want, but it's just pretty awesome.
No, I think I would like. I think I would prefer to ask you a couple more final questions. Kind of related to the last stuff that you talked about, and so I'm gonna basically go back to a question that somebody asked earlier in the stream, where they were asking about. If you thought about having the debugger somehow work with some kind of hot reload code hot reload system, and maybe I should ask you like how hard is it? Because I know that usually hot reload, let's say the simple version where you have the logic of your program implemented as a dynamic library, and then whenever that gets changed, your program reloads that dynamic library. How bad is that for a debugger to make sense of?
Okay, so I'm not really sure. I haven't implemented it myself yet. What I would say is, okay, so already in this debugger, I actually don't even remember what file this is, but yeah, so what I actually do in this debugger, rather than wait for you to launch the executable, I actually just set up like a file system watcher on Linux, right? And watch your executable. And when it changes, that's when I start loading debug info. So that way, when you press run process and you want to launch the process, your symbols are either already loaded or they're in the process of being loaded, right? What I would imagine that if you wanted to do like hot reloading via like a shared object or something, you would do a similar thing for that shared object file itself in addition to the executable. And then you would just sub out all the compile units that were previously in, like all the previously valid compile units. You might swap those out for the new ones, and you just have to know which ones those were and hot swap them out. I wonder if like some weird stuff might go on there when you like actually like load up that DLL. I'm genuinely not sure. This is just all kind of off the cuff, but like if you look at like Ghosty, right, it's got a lot of stuff in there, right? And if you actually do like if you cat proc self maps or whatever, like we do this like batch process, you see there's a bunch of places where all those DLLs get loaded into memory.
Yeah.
I don't know enough about hot reloading to say how this would change, if at all. What I would imagine happens is like if you wanted to replace like you never do this in this case, but like if you want to replace like libgcc, do you just go and assume that this address is unchanged and then the rest of the segment is like you just overwrite all of this stuff in this range? I'm not entirely sure.
I don't know. Would you be able to maybe detect when DL open is being called? Because I guess that would be the moment where something could change.
DL opens a syscall, right?
Good question. I guess at
Function.
some level it has to be.
Might be part of the C standard library. Let's see. DL open.
Not on Linux, says Gimli. Uh-oh.
Mm.
Yeah, I mean, it's probably doing a bunch of clib related stuff potentially, but in there might be, I'm guessing, a syscall at some point.
Yeah. So the reason I ask is because this ptrace syscall, this is actually how strace is implemented. So one of the use cases for it is notify me every time a syscall is made. So
Jacob Lee is pointing out that the syscall is mmap. So
yeah, it's tough.
It's tough. It's tough.
Yeah, ptrace syscall. Yeah.
Yeah.
Or something like that. But
okay.
Yeah. I imagine I could envision a world where you just say like, hey, there's a button in the debugger. Just go click the button and it'll reload your symbols. Though, like if you have that bespoke use case. Yeah, maybe it just refreshes all symbols at that point. Not sure. It's a good question.
So what are your long-term sustainability plans?
None right now, honestly. Feel free to donate on my GitHub sponsors page. But my long-term sustainability plans are: I have a day job and I like my day job, and I'm going to keep working at my day job. But I also need a debugger. So yeah, I'm not sure. I actually had talked briefly with Andrew about this, and Loris actually, we had chatted about this as well. Like, I was thinking about maybe putting this up as like a closed source. Hey, come to this thing, pay $20 or something, and you can just download the binary and run it. And, you know, kind of like something like Sublime Text where you have like a very basic license or something. It didn't really feel right though, because, well, like Linux debuggers just like don't buy things like ever. And so like I think the amount of money that came in from that would be like relatively trivial. And it's actually probably better to like open source it and like get the help of the community and actually like build this like, I don't know, like a little bit of community around it and make it hackable and extensible and forkable, right? I think that's more valuable than like a very small amount of money that I otherwise would have possibly made, but I'm not even sure I would have made anything at all. So join the Discord if you want to keep chatting. I'd love to hear about how I could potentially make it quote unquote more sustainable, but for the time being, yeah, don't really have a long-term plan there.
Okay. I think this was most of it. So if anybody had questions that I didn't end up asking Jim, please follow his advice, join his Discord server. If you go on Zig.show, the show notes for this episode will contain all the links to his blog post, to his repo, just search for mscope on GitHub, you will find it. And yeah, let's, if you're interested, let him know, because that's also nice, you know, when you make something and potential users let you know that they're trying out your stuff. It's nice. Okay, Jim. So is there any final parting words that you want to share before we end the stream?
I just want to say a huge thank you for having me on. It's been awesome. I'm super excited about Zig and the direction it's going. I'm excited to see Zig Showtime back online. I've been watching it for a long time, just kind of lurking around. Yeah, thanks to you and the whole Zig team, and very excited to keep working on this.
Well, thank you for sharing with us your very cool project. So,
yeah, my pleasure.
Thank you. So that's it. And everybody, see you on the next episode of Zig Showtime. Bye-bye.